Here we discuss the concept of conjugate of a complex number. If z is x plus iy is a complex number, the conjugate is represented as z bar, which is equal to x minus iy. I have already discussed the concept of conjugates with you when we were discussing the concept of division of complex numbers. Now we go deep into it, still more properties, etc. So first we will see how a complex number and its conjugate will look like in a geometrical representation. So if you mark P as z x plus iy, then P dash will represent z bar, which is x minus iy. So you can see that z bar will be like a mirror image of z, which is a reflection on the real axis. So why conjugates are very important, we will go into that. And before that we see one example. Suppose 2 plus 3i is z, then z bar is 2 minus 3i. You can see how it will be like a reflection. And conjugates are very much important in completing a division involving complex numbers, as I have already discussed with you. In order to complete a division with a complex number, in case of a division, you will have a complex number in the denominator, and the problem with the complex numbers is you do not know what they are. So to change the denominator into a real number, we need the help of a conjugate. And moreover, you know how you used to do for a surd. When you have a surd or a rational number in the denominator, you used to do the same thing. So that is what is happening. And how this is happening, you just find the product z into z bar. Z is x plus iy and z bar is x minus iy. The product is like a plus b into a minus b, so a square minus b square, and x square minus iy the whole square is I square y square. I square is minus 1, therefore it will become x square plus y square. So you can rest assured that this will be a positive real number. Why? Because both x and y are real, so their squares will be automatically positive. So their sum will be a positive real number. That is why we say that conjugate is very important in the the process of division, because it will make your denominator a positive real number. And here we discuss 6 properties of complex conjugates, which are very useful for you in all the theory based problems. Suppose you have to add 2 complex numbers and then take the conjugate. This answer and the answer you get by adding their conjugate separately will be equal. This can be extended to any number of complex numbers. Similarly, z1 minus z2 bar. That is, if you subtract 2 complex numbers and then take the conjugate, that answer will be equal to the difference of the individual conjugates, z1 bar minus z2 bar. You know very well this cannot be extended. Then z1 into z2 bar, the product, if you are taking the product of 2 complex numbers and then taking the conjugate, this answer will be equal to the product of the individual conjugates, z1 bar into z2 bar. Then as far as the quotient is concerned, z1 bar by z2 the whole bar will be equal to z1 bar by z2 bar under one condition: denominator is not equal to 0. So in all other cases there is no condition, but for quotient alone there will be a condition. Then suppose you have to raise a complex number to power n, then take the complex number. You can always take first the conjugate and then take power n. Z bar, the whole bar is z. If you take a conjugate once, again take the conjugate, the answer will be the original number.